Okay there, ladies and gentlemen, let's go ahead and get started. The purpose of this video is to walk through in much more detail than I was able to provide before how to do the 9 core constructions on the sheet that I gave you guys last Friday called Constructions Day 2. It's the one that's green that you guys worked at in your test groups, but we didn't really get a chance to go through one by one. So if you're here watching this video, I'm going to assume that you want to make sure that you can do all 9 constructions very well with details and maybe some idea how this is actually working. So without further ado, let's just jump into it. So on construction one, which didn't actually cover in class, in fact, I gave you instructions to skip it. Both construction one and construction two are really vital to the rest of these constructions. So in other words, if you're having trouble with 3 through 9, it may be because we don't really understand fully number one or number two. So this is a good place to start. If not, you might want to skip until construction three. So we have to realize our real only tool that we get to use is going to be this compass. And all this compass does is transfer a distance between 2 points. So when you're viewing a compass, please take note that the pin side and the pencil side, that represents 2 points. Of course, then you have the distance between 2 points. So if you're looking at this segment needing to copy it, well, it's really just a matter of opening your compass to that distance. Now, where you transfer to on the page doesn't really matter. I mean, you can literally put in any orientation with any starting point. It's not the starting point that matters, in other words, it's the ending point. So a typical strategy will be to, again, get your compass to the correct length. That'd be step one. Step two, choose a starting point to be your new A. And I'll just put it here. Again, it doesn't really matter. That's just for our use, our ease. And I'm going to go ahead and call it A prime. Okay. Then using the compass, I have not changed the distance. I have not rolled it any wider, any shorter. Place your pin at A, and then cut an arc. So again, kind of keep in mind the whole point of using an arc is that an arc is actually part of a much larger circle. We don't need the entire thing, but in truth, this is the underlying concept under all the constructions. That if I pick any point, if I pick any point on this circle, since it was all made with the same compass with the same radius, literally any of these points can be B. It doesn't matter which one you choose. I can choose B to be right here, or I can choose B to be right here. Again, this is the underlying concept that actually drives all of these constructions. That as long as you're using points that are on the same arc, you're guaranteed the same length. So using our straight edge, connecting points A and B together, I now have the exact segment distance here as I did here. And again, it doesn't matter where I choose B as long as I choose it to be on that arc, not to pick a pun. So this one would actually have been equally good. This length and this length are the same as it would have been from any B prime that I picked on this arc. Okay? So again, just pick any one of those segments, and that actually accomplishes the task, copying the segment. Okay, so once again, just making sure that we have all the steps. Step one, make sure you set your compass distance to AB. Step two, choose an A anywhere on the plane. Step three, pinning your compass at A to make the center of a circle, cut an arc. And then step three, choosing any point B on that arc, say like this one. And then the final step is to connect A and B using a straight edge, thus creating a line. Now again, please note that I have two different examples here because I want to emphasize that any point B is equally good as long as it's on the circle. So that is how to copy a segment. Um, let's go ahead and move right then to part two, or construction two, excuse me, copying the angle ABC below. So I would claim, excuse me, I would claim this construction is actually just like the first construction. In the end, what you're really trying to do is just copy a couple distances. Three to be in fact here. So we have to copy this distance. We have to copy this distance. And then we have to copy this distance. If we can copy those three distances, in other words, if we can copy the points correctly, then simply connecting point A to point B, then B to C, will actually give us the angle. So let's do that. Now, again, I don't think it matters which one we do first. So just because I chose it first, let's do BC first. So the strategy for copying BC will be the same exact strategy we used to copy AB in construction one above. So step one is going to be to set our compass length BC so we can actually take that distance. Choosing a new B point, and again, doesn't matter where it is. So I'll put my new B point to be here. and then using that same compass distance and pinning our compass at B, creating an arc to label all possible C's. Now again, I could have gone around in a full circle, but I don't need the full circle. All I'm really looking for is a possible placement for C, and since I am trying to do a copy, I'll try to orient it roughly the same way. So I'll choose my C to be here. So that's step one. We should now have our first length complete. Now I have to move on to the second length. So again, this one is now finished, so we can forget about that. Now let's go ahead and place our A. Now A is tricky because to place A correctly, you have to actually place two distances at the same time. We have to acknowledge that A has to be this far away from B, and at the same time A has to be this far away from C. So to do this, we're going to actually need two arcs. And again, this is another underlying principle for the more complicated structures that happen later in this packet. So it doesn't matter which one we acknowledge first because we're going to need them both to actually find our distance. So I'm going to go ahead and copy to A first. So again, place your compass and mark that distance. And we have to transfer that distance directly from B. So again, over our new B, in this case B prime, we're going to pin our compass and we're going to create a new arc. So again, we don't actually need the entire circle. We just need kind of a relative location. We know A that should be somewhere on this arc, so we don't need the whole thing. So now we've effectively transferred this distance. So the only one left is that guy. Okay? So again, a basic strategy. Let's go ahead and set our compass to the right distance. So now I have its distance set from C to A. Pin our compass at C. Find the intersection of the two arcs. So as I'm kind of finishing this up, it's worth noting that this strategy works because we're taking advantage of the fact of circles, that all points on a circle are equidistant from a center. So like in this last step, since I made a circle at C using this distance, I know that if I pin myself at C, that any point along this entire radius of the circle will be the same distance from C. So this point right here, where the two arcs intersect, are literally it's literally the only distance that's the same BA as was in the original diagram, and AC as was in the original diagram. Okay. The concept is kind of similar to that of like graphing systems from Algebra 1, where you have two lines but they can only intersect in one place. Except instead of lines, we're actually dealing with arcs. And I do just realize I didn't actually need this line, so please just disregard it. But in the end, that's what we're looking for the transference of an angle. So now taking these two concepts, we're going to extend that in the next video to the more complicated constructions number 3 through number 9.